same guy. It's a content commonly called skylight. So today's lesson will be based on refraction of light at plane surfaces, which is only going from prisms. You see? So refraction of light at plane surfaces. So the point here is how they can have the refractive index of the material to be the sine of the minimum deviation A plus the refractive angle divided by 2 all over sine A all over 2. So how we can have this relation? Because this symbol is representing the refractive index of the material. Bm is telling about the minimum deviation, and A is telling about the refractive angle of the prism. So how can we be able to arrive to set derivation? But the first point, we have to capture what we mean by a deviation. You see, deviation is just a change in direction of a ray of light when it passes through a prism. That's what we mean by deviation. And what we mean by minimum deviation, because it's a condition for us to have this derivation. Minimum deviation simply means when the ray passes symmetrically through a glass prism. When the ray passes symmetrically through the glass prism, when those two rays are parallel, therefore, definitely minimum deviation takes place. But since we consider prisms, what are some of the uses of prism? Mostly we can use prisms in periscopes, we can use prisms in telescopes, we can use prisms in microscopes. Those are some of the basic uses of prisms. But let's consider a triangular glass prism. If we have this triangular glass prism, let's label it as angle A, here is B, and here is C. So this is side AB, this is side AC, and this is side AC. This A here, we are seeing the angle of the prism is this, which is A. But mind you, this triangle is the equilateral triangle. We know an equilateral triangle, all the angles will be 60 degrees throughout, So we have to have points in that. Because most times when you do your practicals, the question will tell you to measure these values. So when you measure it, you must have 60. If you don't have 60, you have 59 or 58, maybe something is wrong. It can either be the error is due to parallax or the error is due to 0. So when we have this prism, let's say if a ray goes to this prism, see, always the ray that goes to a surface, that ray we call it to be the incident ray. If we carefully draw a normal to pass through here, this is the normal. And the angle between the normal and the incident ray, that angle is the incident angle I. You see? So since we have this, so in this process, instead of the angle to continue its straight path, right, there's going to be something that takes place. And that something is what we call what? Refraction. Refraction is just telling of the bending of a light when it encounters a hard surface. Instead of the ray to continue this surface, the ray definitely bends. Instead of it to move this way, this arrow, this direction, it bends, it follows this path. So this is the direction. So since they follow this path, this ray is called this ray is the refracted ray. Is the refracted ray. Because this ray is the incident ray, this ray is the refracted ray. So now the angle between the normal and the refracted ray, that angle is what we call the angle of refraction. You see? So in this case, since we have this ray then, if you observe, if you look through side AB, you will see this ray here to be in straight line with this. When you look through AB, you will see this line to be the same straight line with this ray. So this ray that leaves the surface, we call it to be the emergent ray. See? And if you carefully draw a normal to pass through here, right? This is the normal. So the angle between the normal and the emergent ray, we call that angle to be the emergent angle. So having this emergent angle, here again you can see this ray should have continued this straight path, but due to certain reasons it refracts. You see? So the angle between the refracted ray and this normal, we also have the angle of refraction. Since we have two refractions, let's differentiate them. This refraction I1, when the ray is going to the surface, And this is refraction, R2, when the ray is leaving the surface. So the next point, since this ray and this ray meet at this point, so that angle, let's call it to be the deviation. Since it's the deviation, let's say this angle here, we call it deviation 1, and this angle here, call it to be deviation 2. Because the process of this curve to consider is a deviation that takes place. Deviation is simply when the ray bends, we have deviation. So we have D1 and D2. So this angle of the prism here A is going to be, in geometry, is going to be the same as this angle. So this is just a basic diagram we have to capture before we can be able to derive this. So to derive this now, if we look in geometry, clearly, we can say the angle which goes to the surface, we see I, and we can also consider the angle that leaves the surface E. But if we look to geometry, this line, they intersect, and this angle I must be equal to R1 plus D1. So in geometry, angle I, the incident angle equals to D1, which is this, plus R1, which is this. Let's call it equation 1. If you look again, the emergent angle that leaves, this line intersects this other line. You can see it, right? That E equals to D2 plus R2. This gives us equation 2. Let's add 1 and 2. Add 1 and 2. If we add equation 1 and 2, I plus R gives us I plus E. And D1 plus D2 and plus R1 plus R2. This helps us to have equation 3. So if we move forward again, if we look at the diagram again, this angle A, because simply the exterior angle of a triangle, because this is a triangle, the exterior angle of a triangle is equal to the sum of simply the opposite interior angles. So looking through the diagram, A is going to be equal to R1 and R2. So we can say A equals to R1 and R2. This gives us equation 4. You see? So the next one is the deviation is the same thing, the same principle. D equals to D1 plus D2. The exterior equals to the sum of the opposite interior. So this gives us equation 5. So having this now, the reason how do we have this dm? Minimum deviation takes place. This point is very, very important, very critical. You have to take note of that. Minimum deviation takes place when the ray passes symmetrically through the prism. How the ray passes symmetrically through the prism? We can see this line is parallel to this line. See, always when this line is parallel to this line, this tells us that the ray passes symmetrically through the prism. So when the ray passes symmetrically through the prism, when the ray passes symmetrically through the prism, minimum deviation takes place. So definitely minimum deviation takes place, which is dm. So how that? So what are the conditions for the minimum deviation to take place? Therefore, R1 would equal to what? R2. So R1. So the conditions now we have to take note of. The conditions. So we have to take note of this condition. The first one, R1 equals to R2. That the first refraction angle must be equal to the second refraction angle. And also the first deviation angle is going to be the same as the second deviation angle. The next point again, the angle which goes into the surface, which is I, must be equal to the angle which leaves the surface. So A equals to I. So these are the conditions. When the ray passes symmetrically through the prism, this refracting angle must be parallel to this. So that shows that the ray is symmetrical. So if we capture from equation, let's say from equation 3, which is I plus E equals to D1 plus D2 plus R1 plus R2. So if I equals to E, instead of write E, we represent them to be I, equal D1. If R1 equals to R2, let's represent them to be R. If D1 is same as D2, let's choose a single letter as D. You see, so this D1 is going to be D, this D2 is going to be D, this R is going to be R, and this R is going to be R. So I plus I will give us 2I, D plus D will give us 2D, and R plus R will give us 2R. You see, let's call this equation 6. So having this equation 6, we also recall from this A equals to R1 plus what? R2. So A now, since R1 and R2 are the same, we'll just say R plus R. So A equals to 2R. This gives us equation 7. See, but if we make R the subject, R will be A divided by 2. This is equation 8. That means we divide both sides by 2, both sides by 2. Further, if we look at it at the division, total division D equals to D1 plus D2. So D now, at minimum division, instantly this D becomes Dm. So we are in this D is going to be D, and this D is going to be D. So minimum division, D equals to 2D. You see, so this gives us equation 9. So moving forward, we recall again from this relation from equation 6, which says 2I equals to 2D plus 2R. So 2I equals, what is 2D? 2D is Dm, we substitute it. And what is 2R? 2R, we have it to be the refractive angle of the prism, which is A. So if we make I the subject here, we divide both sides by 2. The minimum deviation from the plus the refractive angle, dividing throughout by 2, these two cancel. So R is going to be Dm plus A divided by 2. This is equation 10. So since we have these values, but our target is how we can have the refractive index of this prism material to be equal to this. So, but we have refractive index of the glass prism. We have it to be sine I all over sine R. So the refractive index is going to be sine I. What is I now? We have it to be this. When we substitute, it's going to be Dm plus A all over 2 and divided by sine. What is the refraction? A refraction from equation 8, we have it to be A upon 2. So this is just the derivation. This is your equation 11. It's just how we can easily derive the refractive index of the glass prism. Thank you all. Stay tuned. Try to subscribe to my YouTube page.